Ladies and gentlemen, please give a warm welcome to conservation biologist and geneticist Natalie Schmitt.
My gosh, you're my new family now. I feel like you're my new family. Is everyone inspired? I mean, my gosh. I just can't believe the caliber of presenters, and I especially love that there's this beautiful theme of inclusion and togetherness through all our speakers, and I'm going to touch on that in my talk. So thank you so much for giving me the opportunity to talk about what has been a relentless commitment and passion for me. It's been a journey that has completely transformed my life. So when I first discovered the enormous potential of DNA, or specifically genetic tools to help us learn more about rare and elusive species, or species that are really difficult to find, I was immediately hooked. Because I love these types of animals. But what are genetic tools exactly? So genetic tools are basically DNA sequences that are unique to an individual, a population, a species, and they can help us learn a lot about plants and animals from the remains that they leave behind. So skin, bone, hair, fecal samples, etc. There we go. So I study Antarctic blue whales and snow leopards. And from the DNA that I can extract from their skin samples and fecal samples, I can estimate abundance, I can look at population connectivity. I can even track individual movement. So these tools are really valuable and important for conservation. But to analyze the DNA in these samples, we more often than not need to have access to sophisticated and expensive laboratory facilities. And it wasn't until I started working with some of the remote communities in the Himalayas of Nepal around snow leopard conservation. Clearly, they don't have access to these types of facilities, that I realized that this is actually a big problem for conservation. In fact, I'd go so far as to say that this is one of the biggest problems that is preventing us from putting a stop to biodiversity loss. Our ability to detect wildlife from their remains, being largely laboratory-based, is expensive, it's time-consuming, and it requires considerable expertise, which effectively removes most of the world, excludes most of the world, from participating in global conservation efforts. Many developing countries simply do not have access to these types of laboratory facilities, and amongst some of those countries, there are some where it's illegal to actually send samples out for analysis. And this is having huge consequences. So take the illegal wildlife trade. The illegal wildlife trade is a multi-billion-dollar problem. It has had huge ecological, economic, and national security consequences. But it's the inability of customs officers, law enforcement, anti-poaching squads to be able to distinguish between a legal sample versus an illegal sample quickly, easily, and inexpensively that is one of the biggest issues in the enforcement and prosecution of the illegal wildlife trade. I mentioned fecal samples. Fecal sampling is actually a really valuable method to help us monitor endangered species in the wild. The problem with this is, and this is a personal example, You'll traipse all across, well, not all across, you'll be climbing mountains in the Himalayas trying to find snow leopard poo samples. And that can take about 3 weeks, and let me tell you, it's not easy. You'll send those samples off to a lab to get them analysed, only to find that most of those samples belong to either leopard or wolf. And it's not because I'm hopeless, this is actually more common than you think. And so this can be a huge waste of time and resources. And if there's anything we've learned from this pandemic, it's how necessary and important it is to be able to detect wildlife pathogens on the spot. I don't know if anyone's heard of the chytrid fungus that is killing amphibian species around the world. I didn't actually realize that this is largely spread through the legal trade in amphibians. Now, if customs officers can't detect that pathogen on the spot at ports, then we can't hope to stop the spread of these pathogens in their tracks. Oop. And an issue that's very dear to my heart, if we can't provide conservation technologies that everybody can use and communities so that they can contribute to global conservation efforts, then we are effectively eliminating probably the most important component to successful and sustainable conservation efforts. So what would make a species detection technology truly useful for conservation? Well, we're often dealing with very degraded samples and small traces of DNA, so it needs to be sensitive. We really need to be able to distinguish between closely related species, so it needs to be specific. It needs to be portable, easy to use, and inexpensive. There are portable devices out there, like portable sequencing devices and qPCR machines, but they're still really expensive. The DNA often needs to be sequenced, so it attracts high error rates. Sample processing is complex, and it, of course, requires substantial expertise. So we so dearly need a more inclusive species detection technology, which is why when I stumbled across a scientific manuscript, and I'm not kidding you, I literally randomly found this paper that had been written by a biomedical lab at McMaster University. They developed this very elegant, paper-based approach to detecting bacteria in food and water samples. And I literally had this eureka moment where I thought, my gosh, if we could adapt this to species detection, this could have a huge impact on conservation. And it's strange, you know, I had no hesitation in literally giving up my career and a lot of other things to travel across the other side of the world to Canada to work with this team to see if we could do this, because this is important. So we're still in the research and development phase, but this is kind of what the technology will look like. So it will consist of a platform like this, with a digital display so data can be uploaded. But the magic really occurs on these paper-based strips. So we have reagents that are preserved and dried and printed onto those paper strips that are specific for your species of interest. And it will work in a very similar way to your COVID rapid antigen tests. So first of all, we free the DNA up in a solution. We apply it to that paper platform where the paper grabs onto that genomic DNA. And if this is your species of interest, it will initiate an amplification reaction and it will issue a color change. So this is a quick reaction, occurs in less than 30 minutes. Low error rates because you don't need to sequence this DNA, and because the reagents are dried and printed directly onto the paper, it keeps it inexpensive, it keeps it easy to use and highly replicable. And I seriously pinch myself every day that I get to work with 3 of the world's experts in biosensor development, for human health, that is. So there's Dr. Yingfu Li, who specializes in functional nucleic acids. Dr. Carlos Felipe specializes in designing paper-based platforms for biosensors. And Dr. Leila Soleimani, who is the Canadian chair in miniaturized biomedical devices. I think I've got a team match made in heaven. And we have funding from both the Canadian government and industry to first develop this technology for caribou fecal detection. So caribou are a very important and threatened species in Canada, and it's essential that operations from industry and government do not interfere with caribou migratory routes. So this technology will save industry and government a lot of money, time, and expertise. But what I'm really passionate about is putting this technology in the hands of the Indigenous people that live in these areas to empower them to be able to contribute to decision making. We've received incredible interest from the conservation world. We have partnerships in place with the South African government, who are interested in using this technology for lion bone and rhino horn detection. Partnerships with the WCS, Wildlife Conservation Society, the Global Snow Leopard Ecological Protection Program that encompasses all 12 of the snow leopard range countries, the Senckenberg Institute, and the Autonomous University of Mexico. And yeah, we've got a whole lot of media. But just last week, I received an email to say that we've been recognized by CITES in a report. So if anyone doesn't know who CITES is, it's a global multilateral treaty that protects endangered species in trade. And for me, the many years that I've worked on this is just incredible validation of just how much this type of technology is needed for the world of conservation. We need a little bit more money to fast-track the development of the core technology for caribou, but what I'm really interested in is expanding this technology to all the big cat species and for multiple sample types, so skin, bone, hair, saliva. Why the big cat species? And it's not just because I love them, but they are crucially important ecologically, economically, and politically. They feature very heavily in the illegal wildlife trade, and they're responsible for most of the human-wildlife conflicts around the world. And then our second raise, we want to expand that technology to encompass many species and many applications. We've had a lot of interest. So with just a small amount of investment, this technology stands to save governments, institutions, industry, all sorts of organizations, a lot of money and time, and increase their capacity for mitigation. But what I'm really excited about is being able to put this technology in the hands of everyday people, because we can't solve the issue of biodiversity loss unless we work together and empower the world to contribute to conservation. So I just wanted to end with a little video on what we're developing. What will you be willing to do for an idea you know will be a game changer for conservation?
But this technology is essential.
So the idea is that we can hand these kits out to the local villages and we can obtain that data and then get a much more accurate estimate of abundance.
Efficient and faster and less expensive. immediately was struck by how relevant the technology is, what is the incredible potential of this technology, and I'm really clear that this is the future.
Please join us. There's never been a greater urgency. Thank you, everyone, so much. It's been a very challenging journey, but one that I would never, ever change. I want to thank and give recognition to my funders and my partners. Without them, this just would not be possible. And I actually want to end with an opportunity for any of you that are interested. So I work with an NGO called PANGI, and they focus on community snow leopard conservation in some of the communities in the remote Himalayas of Nepal. We have a project that we're initiating, a multi-year project in the far western region of Nepal, in Dolpo, and we're looking to raise money for this project. So we would like any of you who are interested in joining us on an expedition next year to help us with this. This is one of the most remote and pristine regions on Earth, and I've been told one of the very few places that you have a good chance of seeing a snow leopard. So please come and talk to me if you're interested. Thank you so much.